Friends, so here I am your Arka sir. So I have come with a fresh and new episode for NEET JEE special, okay, on physics. So if you missed my previous episode, I already uploaded 3 episodes, okay. So if you missed, you can see that, okay, in my channel, okay, Physics Scholar. And if you have not subscribed yet, subscribe it as early as possible so that you can get all the notification of my uploadings, okay. So if you can follow the channel from the beginning, I am very much sure that you can crack the examination very easily and your knowledge and concept will be clear. So without further delay, let us start the today's episode. So let us move to the first problem, okay. First questions: a copper cylindrical tube has inner radius A and outer radius B. The resistivity is rho, okay. So resistivity is rho. The resistance of the cylinder between the two ends, okay, will be what? 4 options are given: rho into L. L means length. L means length. Rho into L by B square minus A square. Rho into L by 2 pi into B minus A. Rho into L by pi into B square minus square. And D number is pi into B square minus square by rho into L, okay. So which option will be correct? Okay, that we have to find out. Clear? Now the one had cylinder A, solid cylinder of radius B. We can suppose that it is made of 2 cylindrical cylinder. That means one cylinder, okay, and it is solid. That means what? We can consider 2 cylinders, okay, 2 cylinders. One is inserted on another, okay. Let the internal radius is A and the outer side is X, okay, and clear. Now the thing is that the cylinder consists of radius A and outer part joint along the length concentrically one side another. If IA and IX are the current flowing through the inner and outer cylinder, that means here the current flowing is IA and here the outside is IX, okay. That is the radius of this cylinder, IX, okay, outside cylinders, okay, are flowing, okay. And then what we can write? I total. I total means the total current flowing through the outside body, that means IB. IB means what? Outer resistance of the overall cylinder, clear, is equal to what? 2 cylinder, and it is a cylinder, okay. So 2 cylinders are there, okay. So solid cylinder, so inside and one cylinder and another cylinder is inserted with that. That's why it is solid, okay. It is solid, clear. Then what will happen? So now IA is equal to what? IB is equal to IA plus IX. IA means what? Inside radius of the cylinder, and IX means the outside cylinder, okay. So what is V is equal to what we know? V is equal to I into R. Therefore what? I is equal to V by R, clear. So that's the same thing. So IB means what? V by RB is equal to IA means what? V by RA plus IX means V by RX, where RA is equal to resistance, okay. Resistance, RA is equal to what? Resistance of inner cylinder and RX resistance of outer cylinder, okay, resistance of outer cylinder, clear. Now so what? Now what we know? R is equal to rho into L by A. A means cross sectional area, clear. So what we can write from here? RB is equal to what? Rho into L by what is the area? Area means pi r square, okay. Pi r square, here R is equal to B, so rho into L by pi B square. RA is equal to rho into A by L by pi A square, okay. So what we can write? So we are putting the values over here, okay, we are putting the values over here. So RA is equal to what? RB plus RX, clear. RA is equal to RB plus RX, clear. So 1 by RB is equal to what? We are putting the values of RA and RB over here, okay, pi into R rho L, okay, into B square minus A square. So that is what? That is coming, clear. RB is equal to pi into rho, that means what? RX is equal to rho L divided by pi into B square minus A square, okay. So that means what? RB is equal to this, clear. So Rx is equal to, so it will be what? 1 by RB is equal to 1 by RA plus 1 by Rx, clear. So RB's value is this, clear. So now the thing is that how we can do it, okay. I am doing the step. What? 1 by RB is equal to 1 by RA plus 1 by Rx, clear. So 1 by Rx is equal to what? 1 by RB minus 1 by RA. So what is 1 by RB? 1 by RB means what? RB means rho L, rho into L by pi b square minus 1 by what is RA? RA means rho into L divided by pi a square. Clear? So that means what? Pi b square divided by rho L, okay, minus pi a square divided by rho into L. Okay, so rho L, okay, will be what? Will be LCM. So pi common, so b square minus a square. Okay, so that means what? Rx means, so Rx means what? Rho into L divided by pi into b square minus a square. Okay, so this is coming this one. Clear? So how we are doing the sum? So let us one cylinder, which is a solid cylinder. So one cylinder is what? Inserted into the another. Clear? So now the IB is equal to what? IA plus IX. Okay. So now what? V by RB is equal to V by RA. IA means what? V by RA plus IX means V by RX. Clear? So RA and RB you can find out what? RB is equal to rho L by pi b square and R is equal to rho L by pi square. So by putting the value of RA and RB we can find out the value of Rx. Okay. So Rx is equal to rho L by pi into b square minus a square. So that means what? Option C is correct. Okay. So the answer will be option C. So this type of sums very common for the JEE or NEET examination in physics. Clear? The physics actually most of the students actually getting fear of the numeric problems of physics. But if you practice and if you continue to watch my channel, so it will be very much easier for you and you can get rid of your problems. Okay. So students, hope you have understood this. If you have any doubts, anything you want to ask, you can write in comments. Clear? So without further delay, now let us move to the problem number 2. Okay students, now let us move to the problem number 2. Clear? So the equivalent resistance between A and B, between these two, okay, we have to find out. Clear? That means we have to see the combination, which are in series, which are in parallel. So always two things you have to remember. The first one is where the current is dividing. Clear? That means they are what? They are parallel. Clear? And when the same current is flowing to the resistances, that means they are in series. See? So here between A and B. So that means between this point and this point. So same current, what? Here the current will be divided. Clear? Here the current will be divided and this current will flow from here also. Clear? That means 5 and 8 ohms are in series because the same current will come here and will flow here. Clear? And here the current will divide in two parts. That means this will be in series with this will be in parallel. Suppose it is I1, it is I2. Clear? So it is also I1 and it will be what? I2. Clear? So here the current is dividing. So that means what? This will be in this 5 ohms. Okay? 5 ohms and 8 ohms. 8 ohms are in series. Okay. So equivalent resistance say R1 is equal to 5 plus 8 is equal to 13 ohms. Clear? Now this 13 ohms and this 6 ohms are in parallel. Okay, parallel. So equivalent resistance, what we can write? R2, 1 by R2 is equal to what? Or we can write R2, two resistance are in parallel. That means R2 is equal to 13 into 6 by 13 plus 6. Okay. Okay, 78 by 19 ohms. Clear? That is R2. Clear? If the two resistances are in parallel, that means what? Product divided by summation of the two resistances. That is the parallel for the parallel circuit. Okay. So now see, the same current will flow through this. That means 4 and 5 are in series. Clear? Then that all are in series. The same current will flow, no branching. So the total resistance between A and B. Clear? Total resistance between A and B, what will be there? Okay. This 4 plus 5 R is equal to 4 plus 5 plus what? 78 by 19 is equal to 19, 76, 78. Clear? 249, 19. That means what is coming? 13.11 ohms. That means, okay, option A. Clear? 13.11 means what? Option A. 13.1. Clear? So, what will be the right answer? The right answer will be what? Option A. Clear? 13.1 ohms. Clear? So, I am explaining it once again, students. So, here suppose the current I is coming. So, it will divide into two parts, I1 and I2. I1 will come here and will come through this. Clear? Here it is also I1, here it is also I1. So, this branch it is I2. Clear? So, that means 5 and 6 are in series. Okay? Then 5 and 8 ohms are in series. So, the equivalent resistance 5 plus 8 is equal to 13 ohm. Clear? This 13 along with this 6 is parallel because here the current is divided. Clear? Now, the thing is that, so that means what? R2 is equal to product if the two resistances are in parallel. Actual formula is what? 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the actual formula. Clear? But here as they are two resistances are parallel, then what? The product divided by the summation. Clear? The product of two resistances divided by summation of the two resistances. Clear? Now it is 78 by 19 ohms. So the resistance between A and B, that means what? The same current will flow here and here. Okay? That means what? The these three are in series now. So 4, 5 and 78 by 19 are in series. So the equivalent resistance very simple. We have to add, just adding. Okay, the normal sum now. Okay, class 5 standards. So 13.11 or 13.1 ohms. Okay. So hope you have understood this. So this type of circuit sum. Okay, numerical sum. Very often it comes in the examination like NEET, joint, even if in the class 12 in the board examination, okay, of class 12. Clear? So hope you have understood this. Okay. So now without further delay, let us go to the problem number 3 of today's episode. So students, here the next problem number 3. N resistors, each of resistance capital R first combined to give the maximum equivalent resistance, then combine to give the minimum equivalent resistance. Now what is maximum if they are connected in series, and what is minimum if they are connected in parallel? So very easy. Clear? So to get the maximum equivalent resistance, they must have to be connected in series, and to get the minimum equivalent resistance, they must have to be connected in parallel. Okay. So what will be the ratio, okay, of their equivalent resistances when they are to the what maximum to minimum? Okay. That means when they are connected in series and when they are connected in parallel. Clear? Now it's very easy. So what the when they are connected in series, let equivalent resistance is R1. Okay. So that means what? R1 is equal to R plus R plus R plus R plus dot up to n terms. So that means what? R into n. Clear? So that is the equivalent resistance. Okay. So when they are connected in parallel, then what? Let equivalent resistance is R2. So what we can write? 1 by R2 is equal to 1 by R plus 1 by R plus 1 by R plus, okay, dot up to n terms. Okay. That means what? N by R. Okay. So that means what? 1 by R2 is equal to n by R. So R2 is equal to R by n. Clear? So now what? Maximum to minimum. That means maximum is R1 divided by R2 is equal to what? R1 means R into n. Rn divided by what? R by n. Clear? So this will be cancelled, n square. So that is what? That is the maximum, the ratio of the maximum and minimum resistance of the combination. So which option is correct? Option number B. So here the answer will be B, okay, and the option is n square. So this option is correct. Clear? So hope you have understood this. Now what is that? When the resistance are connected in series, so equivalent resistance will be Rn, and that means R plus R plus R plus R up to n terms. Clear? When they are connected in parallel, then the equivalent resistance will be n by R, 1 by R plus 1 by R plus 1 by R. How many terms? Up to n terms. So it will be n by R. Clear? Now, so R2 will be what? R by n. Okay, it will be the reciprocal. So R2 will be the R by n. So R1 is to R2, or R1 by R2 is equal to what? Rn by R by n. Okay, RR will be cancelled, so it will be n square. Clear? So option in B will be correct. Here it is n square. Clear? So remember the things, when we are getting the maximum resistance, then the resistances are connected equivalent resistance, then the resistances needs to be connected in series. And when we are getting the minimum equivalent resistance, then the resistances are, needs to be connected in parallel. Clear? So this is very easy sum. Little bit concept you have to use. Okay, you can easily do the sum. So hope you have understood this. Now without further delay, let us move to the sum number or the question number 4 for today's episode. So students, here it is now the problem number 4 for today's episode. So another circuit is given and the resistances are given. Clear? Another circuit is given, so we have to find out the equivalent resistance between A and B. Okay. So this is the circuit actually. This is the circuit actually. Clear? Now how the thing is that it is point A, it is point B. See, if the current enters, okay, then what will happen? The same current will flow like this, so no branching. The same current will flow like this. Clear? To all the same current. Suppose it is current I, so it will be also I, 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 it will be also I. Clear? That means what? There is no separation of currents will be there, or branching of current, okay, splitting of currents will be there. The same current will flow through all the resistances. That means what? All are connected in what? Series. Okay. So equivalent resistance, very easy sum. So equivalent resistance, if it is connected in that, if you can find out whether it is in series or parallel, equivalent resistance is very easy. So equivalent resistance for series is what? Sum of all the resistances. Okay, sum of all the resistances. That means, okay, 18 ohms. So what is the option? Option B will be correct. So answer will be option B. Okay, 18 ohms. Clear? So that will be your answer. So here you see very easy sum. By looking the circuit you may be confused, but here the same current is flowing through all the branches. That means what? These all the resistances are connected in series. So equivalent resistance in case of a series circuit is what? Sum of all the resistances. Clear? So how the 3 plus 4 plus 5 plus 6. Okay, so that will be your answer. Whatever the value, if the value is changed, you can you have to put the value over here and you will get the answer. That will be the correct answer. Clear? So hope you have understood this. Clear? So the equivalent resistance of the given network is 18 ohms. Clear? Because all the resistances are connected in series. So this type of problems, okay, very easy. Okay, only you have to understand whether they are connected in series or parallel. Clear? So hope you have understood this. So now without further delay, let us move to the problem number 5. Okay students, now let us move to the question number 5 of today's episode. Clear? The correct combination of 3 resistors are given 1, 2 and 3 ohms. Okay, to get the equivalent resistance 11 by 5 ohms is, okay. So 4 options are given. Okay. So very easy, we have to check which option is correct. Clear? If this type of questions comes in the examination, then we have to check which option is correct. Okay. All are connected in parallel. All are connected in parallel means what? 1 by R is equal to 1 by 1 plus 1 by 2 plus 1 by 3. Let us check. Okay, 6 will be the LCM. So it will be what? 6 plus 3 plus 2. That means 11 by 6. Okay. So R is equal to 6 by 11. It is given 11 by 5. So it is not correct. Clear? So option A is not correct. Clear? All are in series. All are in series means equivalent resistance what? The sum of all. So 1 plus 2 plus 3. That means what? 6 ohms. So 6 ohm is not there. Okay, so option B is not correct. Clear? So option A and option B is not correct. Now let us move to option C. Option C means 1 and 2 are in parallel. That means equivalent resistance R is equal to 1 into 2 divided by 1 plus 2. That means what? 2 by 3. Clear? And 3 is series and what? 3 ohm is in series to both. That means what? 2 by 3 plus 3, the total resistance. Okay. Total resistance R1 is equal to this. Okay. So 3, so 2 plus 9 is equal to 11 by 3. Clear? So 11 by 3 it is not correct, it is 11 by 5. So this option is also not correct. So technically this option should be correct because 3 are not correct, but we will also check this. Okay, we will check this. What? 2 and 3 are in parallel. So equivalent resistance R is equal to 2 and 3 are in parallel. So the equivalent 2 into 3 by 2 plus 3 is equal to 6 by 5, and it is series with 1. So what? Total resistance. Okay, total resistance R1 is equal to what? 6 by 5 plus 1. Okay, is equal to 5 will be LCM. 6 plus 5 is equal to 11 by 5. 11 by 5 ohms. So this is correct. Clear? So we checked. So the answer will be option D. Clear? Option D will be the correct answer. Answer will be option D. 11 by 5 we are getting. So now how to do? Very easy. So if they are all connected in parallel, so equivalent resistance what? The reciprocal of equivalent resistance will be what? 1 by 1 plus 1 by 2 plus 1 by 3. So 11 by 6. So R is equal to 6 by 11, which is not matching. So this option will not be correct. Clear? Now all the connected in series, that means sum up all the 3 resistances. So 1 plus 2 plus 3 is 6, which is not correct. Clear? Now option third, 1 and 2 are parallel. So equivalent resistance is what? 1 into 2 by 1 plus 2, that means 2 by 3. And it is, and the 3 is in series with them. So 2 by 3 plus 3, that means 11 by 3. So it is coming given 11 by 5. So option 3 is not correct. Then we can say option 4 should be the answer. But we have to check it once, okay, before writing. So R is equal to what? 2 and 3 are in parallel. So 2 into 3 by 2 plus 3. Clear? 2 resistance and parallel. Product by sum. Clear? So 6 by 5. Now total resistance and 1 is in series with them. So 6 by 5 plus 1. Clear? So 5 LCM, 6 plus 5, 11 by 5. It is matching. So the option D will be correct. Okay. So this type of questions may come very easy to solve if you can practice it. Okay, multiple times at home. All the problems whatever I will do in all the episodes, you have to practice repeatedly. And if you can do that, I am very much sure that you can solve this type of problems which will come in the examination with full confidence. Clear? So now without further delay, let us move to the question number 6. Okay students, so here for the problem number 6 of today's episode, another picture is given, the circuit is given. Clear? We have to find out the equivalent resistance between the point A and point B. Clear? Now how to do? First we have to check. Okay, so A will be the entry level of current and B will be the exit level point of current. Clear? Now we have to check where the current is dividing and where. So the 3 basically square. Okay, identical squares are there. Okay, that these 2 resistances are 3 and these 2 resistances are 2 ohm each. Okay, so now if we can find out the equivalent resistance of the, suppose this is the first square, it is second, and it is the third number of square. Clear? Now if we can find out the equivalent resistance of this portion, so that will be same for this and this, and the same current is flowing, okay, through over this. That means what? First here, suppose this is the current. Okay, so this will be split into 2 parts. Okay, the same current, suppose it is I current and it is what? I1, it is I2. So here it will be also I1 and here it will be also I2. Then I1, I2 will mixed over here and it will be I again. Okay, so that means what? See here, these 2 are same current is flowing. Same current is flowing among these. These 2 are in series. So for segment 1, clear? What? 3 and 3 ohms are in series. Okay, therefore equivalent resistance R1 is equal to what? Very easy, 3 plus 3 is equal to 6 ohms. Clear? And 2 and 2 are also in series. Okay, this same current is flowing. So R2 is equal to, then what? 2 and 2 ohms are in series. Clear? So equivalent resistance R2 is equal to what? 2 plus 2 is equal to 4 ohms. Clear? But this R1 and R2 are in parallel because it is splitting over here. Okay, so equivalent resistance, okay, R dash is equal to what? R1 into R2 by R1 plus R2. What is R1? 6. 6 into 4 divided by 6 plus 4. So 24 by 10. That means 12 by 5 ohms. Clear? So 12 by 5 ohms. Clear? Now the same Okay, so equivalent resistance for segment 2 and 3 are also 12.5 ohms and 12 by 5, not point, 12 by 5 ohms respectively. Okay, then what happened? So these are all in series because the same current will flow through this. Here it is also I, here it will be also I. Clear? So the same current is flowing. Okay, so that means what? The total equivalent resistance, okay, তারপর R is equal to what? Sum of this 12 by 5 plus 12 by 5 plus 12 by 5, okay. So 5 will be the LCM, so 12 plus 12 plus 12, 36 by 5. So 36 by 5 means option number C. So which option is correct? So answer will be option number C, 36 by 5 ohms. Okay. So option number C will be correct. Clear? So it is very easy. So I am again explaining. Okay. So here the current will come and here it will be split into two parts, I1 and I2. The same current will flow through here also, I1 and I1. Clear? 2, 3 and 3. So these two are in series. So equivalent resistance will be 6. And the same current I2 and I2 will flow through this. That means 2 plus 2 means 4. Okay. So these two means this portion and these portions are in parallel because here the current is splitting into two parts, I1 and I2. So that means what? R1 into R2 by R1 plus R2. So 6 into 4 by 6 plus 4 is equal to 12 by 5. Clear? 6 for the 24 and 6 plus 4 means 10. So 12 by 5. So the 12 by 5 will be same for this and for this. Okay, we don't have to do it again because it is same. Same value is given. If the value is different, then we have to do it. Clear? Now the equivalent resistance, then these three are in what? Series. Okay, one after another it is connecting and same current is flowing. That means these three are in series. Equivalent resistance are only the summation. Okay, the sum we have to do. So it is coming 36 by 5. So option number C is correct. Clear? So hope you have understood this. Very simple. Only you have to calculate the value of the combination of the resistances. Okay, whether it is in series or parallel. That we have to identify. Clear? And if it is said that the maximum equivalent resistance that should be connected in series, and to find out the minimum equivalent resistance, the resistance says all the resistances should be connected in parallel. That we have to keep in your mind. Okay. So hope you have understood this. So now without further delay, let us move to the problem number or question number 7 of today's episode. So students, here the problem number 7 of today's episode. Clear? Let us start. 5 equal resistances of 10 ohms, so 1, 2, 3, 4, 5, clear, are connected in this way as shown in the figure. So we have to find out the equivalent resistance. That means we have to find out which are in parallel and which are in series. Okay. So only we have to do that and easily we can find out the answer. Okay. So now see, from A, if the current is flowing, all of you see it carefully. If the current is entering from A and coming out from B. Okay. Empty path and existing path. Okay. So now suppose it is the main the flow of current is I. So clear what no resistance is there. So the same I will be here. Clear. So I will come. That means our same these two through these two the same current will flow. That means these two are connected in series. Clear. These two are connected in series. Here it will be splitted. Okay. It will be splitted into two parts. Okay. So and in these two, so the same current will flow. So these two are also connected in series, but here it will be splitted. Okay, here it will also be splitted. That means what? These three are connected in parallel. That means what? That means what will happen? Clear? Here 10 ohms for these two and 10 ohms. 10 ohms are in series. Clear? So equivalent resistance R1 is equal to what? 10 plus 10, very easy, 10 plus 10 ohms. Clear? Now these two 10, okay, at the extreme right. Okay, so this in case of these two again 10 ohms and 10 ohms are in are in series. So equivalent resistance what? R2 is equal to what? 10 plus 10. Okay. That means what? 20 ohms. Clear? Now this 20 and this 10 are in what? Parallel. Okay. That means equivalent resistance what? 1 by R is equal to 1 by 20 plus 1 by 20 plus 1 by 10. Clear? So this, that means what? R1, R2 and 10 ohms are in parallel. Clear? R1 means what? 20, R2 means 20 and this 10. These three are in parallel. Clear? So that means what? 20 will be the LCM. So 1 plus 1 plus 2. Clear? So 1 by R is equal to what? 5 by 20. That means what? 4 by 20. That means what? 5. Clear? So R is equal to 5 ohms. Okay. So which is 5 ohms? Option B. So answer will be what? Option B. That will be the correct answer. Clear? So now see how what is coming here. The same kind will flow through this 10 and this 10. That means these two are in series. Clear? So that's why the series combination, the equivalent resistance will be the sum. That means 10 plus 10 is equal to 20. The same kind will flow through these resistances. So these two are also in series. So again what? It is R2 will be 10 plus 10, that means 20. Now here this 20, this 20 and this 10 are in parallel. Clear? So that means R1, R2 and 10 are in parallel. That means equivalent resistance 1 by R. Okay, reciprocal of the equivalent resistance 1 by R is equal to, here it is not 2 number of resistances, it is 3 number of resistances. So that's why 1 by R is 1 by 20 plus 1 by 20 plus 1 by 10, that means 4 by 20 and 5 ohm. Then option B is correct. Clear? So students, hope you have understood this. Now without further delay, let us move to the problem number 8. Okay students, so here the equivalent resistance of the series combination of 4 equal resistance is S, and and when they are joined in parallel, the total resistance is P, and the relation between P and S is equal to NP. We have to find the value of N. Clear? So you remember I solved one sum. Okay, the ratio between the maximum and minimum resistance is N square. Okay, so it will be like that only. Okay, so by that what? How many number of resistances are there? 4. Okay, so it will be what? 16. 4 square means 16. Okay, so that is the short process I told you. But now I will also solve this. Okay, so how I will solve? So the 4 resistances, suppose these are R. Okay, these are R. So suppose this R. So when they are connected in series, then what? Equivalent resistance, suppose R1 is equal to what? R plus R plus R plus R is equal to 4R. Clear? So this is 4R. Now when they are connected in, so this is what? This is, they are connected in what? They are connected in, this is R. So they are, when they are connected in parallel, then what? Equivalent resistance 1 by R2 is equal to 1 by R plus 1 by R plus 1 by R plus 1 by R. Okay, is equal to what? 4 by R. So R2 is equal to what? R2 is equal to it's not 4 and it is R. Okay, R2 is equal to what? Then R by 4. Therefore R1 by, and what? It is nothing but it is what? R1 is equal to what? It is written as S. So S is equal to 4R. And here R2 is written what? As P. So P is equal to what? Then R by 4. Okay. So S by P is equal to what? N. Okay. So what is the value of S? The value of S is what? S is 4R divided by R by 4. Okay. R by 4. Clear? So this will be cancelled. So 4 into 4 is equal to 16. So what is the value of N? The value of N will be 16. So it will be, answer will be option 3rd. Okay, option 3rd. It will be your answer. Clear? So how to find out? So what? The total resistance is given as, okay. So when they are connected in series, R plus R plus R plus R is equal to 4R, so S is equal to 4R. And when they are connected in parallel, so what? 1 by R2 is equal to 1 by R plus 1 by R plus 1 by R plus 1 by R is equal to 4 by R, clear? Now the R2 is equal to what? Actually it is the reciprocal, it is the actual total resistance. When they are connected in parallel, it will be R by 4, so it is given at P, so P is equal to R by 4. So here it is given S is equal to NP, so S by P is equal to what? N, okay. What is the value of S? 4R. And what is the value of P? R by 4. So it is what? 4 will be cancelled. So 4 into 4, that means 16. So that means what? Nothing but N, okay. S by P is equal to N, so S by P is equal to 16. The value of N will be 16, clear? So I already we have done one sum. If the N number of equal resistances are connected in series as well as in parallel, then the equivalent maximum resistance to the equivalent minimum resistance will be N square. So here 4, that means N square means what? 16. So this will be 16, clear? So in short process also we can do, okay. But here actually how we solve this problem, clear? So student, hope you have understood this. So here the option number 3rd or option number C will be correct, okay. So hope you understand this. So without further delay, now let us move to the problem number 9. Okay students, so here every value of every resistors are 3 ohms, clear? So 4 combinations are given, okay, in form of the electrical circuit. Now we have to find out which circuit is correct, so that the equivalent resistance is 7 ohm, clear? So now we have to do this, we have to check. So see, for circuit 1, these 3 are what? These 3 same kind will flow, so these 3 are in series, clear? These 3 are in series, okay. So what will be, and each value is 3 ohm. So equivalent resistance is equal to what? 3 plus 3 plus 3 is equal to 9 ohms. So it is 7 given. So this option is not correct, clear? This option A is not correct. Now option B, see. So if the current is coming over here, so it will be split into 3 parts, clear? That means these and these are in parallel, clear? So these 3 are in parallel. So equivalent resistance, okay, 1 by R actually, this is R, okay. So what we can write? 1 by R is equal to 1 by 3 plus 1 by 3 plus 1 by 3 is equal to what we can write? 3 by 3, that means 1. So R is equal to also 1 ohms. So it is 7 ohms is given. That means option B is also not correct, clear? Option B is not also correct. Now let us move to option C, okay. Option C, so this what kind will come and it will be splitted over here. So these 2 are in parallel, okay, and this is in series with this, okay. So these 2 are in parallel. So what? 3 ohms and 3 ohms are in parallel, okay. So what you can write? 1 by R1 is equal to 1 by 3 plus 1 by 3. That means 3 will be the LCM, 2 by 3. So R1 is equal to 3 by 2. Therefore total resistance is equal to what? 3 plus this, okay, this and in series, clear? So 2 will be LCM, 6 plus 3 is equal to 9 by 2. It is 7 given, clear? That means this option is not correct. The which option is left? D. So we can write D, but I will also check whether D is correct or not, okay. So now this see here, this and this are in parallel because the current will be divided at this point in 3 parts. So that means what? 3 ohms are in parallel, okay, are in parallel. So 1 by R is equal to 1 by 3 plus 1 by 3 plus 1 by 3 is equal to 3 by 3, okay, is equal to 1. That means R is equal to 1. So along with this, these 3 ohms and these 3 ohms are in series, okay. So 3 ohms, 1 ohms, 1 ohms and 3 ohms are in series. So total resistance is equal to what? 3 plus 1 plus 3 is equal to 7 ohms, okay. So what is coming? 7 ohms is given. That means option D is correct. Clear? So the option D is correct. 7 ohms. Clear? So now how this type of sum if comes, how we can check? It is what? 3 plus 3 plus 3, 9 ohm. No matter, no question arises because 7 is given. Clear? So that option is wrong. Here 1 by 3 plus 1 by 3 plus 1 by 3 means 3 by 3. Okay, that means 1. Okay, so 7 is given. So this option is also not correct. So here these two are in parallel and these two along with this are in series. Okay, so 3 and 3 are in parallel. So it will be 2 by 3, then means 3 by 2. Clear? And 3 plus 3 by 2, this is in series with the 3 ohms. That means what? 9 by 2, but 7 is given. That means option D is only left. Okay, so that will be the answer, but still we will check, have a look whether 7 is coming or not. So this here 3 and 3 are in parallel, so the equivalent resistance is 1. Clear? And this 3 and this 3 are in series with this one. Clear? So 3, 1 and 3 are in series, so the total resistance what? 3 plus 1 plus 3, that means 7 ohms. Okay, so very easy, that means what? Option 4 is correct. So this circuit is correct. So that if the value of all the resistances is 7, then the equivalent resistance will be the value of all the resistance is 3, then the equivalent resistance will be 7. So this circuit is correct for this problem. Clear? So hope you have understood this. Clear? This type of sum very often it comes in the examination. Okay, so you have to solve this like this way. It is not hard, it is very easy. Only you have to understand which combination are in series and which combinations of resistances are in parallel, and how the current is dividing, okay, in each part of the resistances. Clear? So hope you have understood this. Now let us move to the last but not the least problem of today's episode. Okay students, now let us move to the last problem of today's episode. Clear? So a battery of EMF 15 volt and internal resistance is 4 ohms. If internal resistance is there, that means voltage drop will be there. Clear? If it is connected with the external circuit. Okay, 4 volt is connected to a resistor. If the current in the circuit is 2 ampere and the circuit is closed, when the resistance of the resistors are and the terminal voltage of the battery will be, then the resistance. Okay, so we have to find. So that to suppose this is okay, this is actually the circuit. Okay, this is actually the circuit. Clear? So this is the battery. So this is plus, this is minus. So the main current is I. Okay, which is given what? Which is given 2 ampere. Okay. Now the internal resistance of the battery is 4 ohms. Clear? Now we have to find out these resistance R. Clear? And the EMF of the battery eta is given what? 15 volt. Clear? EMF of the battery eta is given 15 volt. Okay. And clear? And inside the battery also the I current will flow. Clear? So what is the difference between the EMF and the terminal voltage? EMF means when the two terminals of the battery is not connected to the outer circuit. Clear? Then the potential difference between the two plates of the battery is known as EMF of the battery. But when it is connected with the circuit, then what? Then the potential potential difference across the two terminals is known as the voltage. Clear? Basically, when it is connected with the circuit and if the battery have the internal resistance, then what will happen? A voltage drop will be there. So basically, the EMF will be higher, okay, than the voltage of the battery. Okay, either it will be same when it is not connected, or it will be higher with the voltage of the battery. Okay, as there is a voltage drop if the internal resistance of the battery will be there. Okay, so that I have discussed in the current electricity chapter. So here what we can write? Okay, so I is equal to what? I is equal to 2 ampere. Okay, so eta is equal to what? Voltage V. Voltage V is equal to EMF minus voltage drop I into, here I have taken small I, so I am writing I into small r. Okay, that small r is the internal resistance of the battery. Okay, so is equal to what? Is equal to I into capital R. Clear? So that is the voltage, terminal voltage. So I into capital R is equal to eta minus I into small r. Small r means internal resistance of the battery. So what is the value of I? 2 into capital R is equal to what is the value of eta? 15 minus value of I means 2 into 4. Internal resistance of the battery is 4. Clear? So 2 into capital R is equal to 15 minus 8. So 2 into capital R is equal to 7. So capital R is equal to 7 by 2. Therefore R is equal to 3.5. Clear? So this value is 3.5 ohms. Okay? So 3.5 ohms. So either option B or option D will be correct. Clear? Now what we have to find out? Okay, the terminal voltage. Terminal voltage what? V is equal to what? I into external voltage. Clear? So I is equal to 2 into 3.5 is equal to what? 7 volt. Clear? So you have seen that the terminal voltage is 7 volt. Clear? Where the EMF is 15 volt. That means voltage drop is there. Okay. So voltage drop is there 8 volt. Okay. Voltage drop is what? 8 volt. Clear? So now what is the option? That means what? Terminal voltage is 3.5 ohms and terminal the circuit resistance 3.5 ohms and the terminal voltage is 7 volt. So 3.5 ohm and 7 volt. So option D. So answer will be what? Answer will be option D. That will be correct. Clear? So now the thing is that what I am explaining it once again. So a battery of PMF is given 15 volt. Clear? And the internal resistance of the battery, that is smaller, internal resistance of the battery smaller is equal to 4 ohms. Clear? Now the thing is that when the circuit is closed means it is connected with the external circuit and the current is flowing. Clear? Then we have to find out the external resistance as well as the voltage of the battery. Clear? Now what we know, here what is given, I flow of current is equal to 2 ampere. So voltage is equal to what? EMF minus voltage drop due to the internal resistance of the battery. So what is the EMF? So is equal to what? I into capital R. Capital R means the external resistance of the circuit. So what is I? So I into capital R is equal to eta minus I into small r. So I means what? 2 into capital R is equal to what? EMF of the battery is 15 minus I into I means 2 into 4 means internal resistance of the battery. Clear? So 2 into small r is equal to 18 minus 15 minus 8. 2 into capital R is equal to 7. So R is equal to 7 by 2. So R is equal to 3 by 3.5. So now V is equal to what? V is equal to I into capital R. So I into capital I means 2 into R means what? 3.5. So 7. So 3.5 ohms and 7 volt. That will be the value of the external resistance and the voltage of the terminal voltage of the battery when it is connected to the circuit will be 7 volt. That means voltage drop will be 8 volt, 15 minus 7. Clear? Due to the internal resistance of the battery. That means here more than 50%. Okay. Voltage drop will be there. Out of 15, 8 volt voltage drop will be there due to the internal resistance of the battery. Okay. So many problems of such circuits. Okay, when the batteries, the combination of batteries will be there, the battery will be connected in series or parallel or mixed combination, that we will do in the next episode. So students, hope you have understood all the problems which I have solved today, 10 number of problems. Clear? So I will upload many videos on NEET and JEE special episodes. So hope you are enjoying of your study. Clear? Because if you can concentrate on the videos and you can do all the problems, okay, theoretical or conceptual or numerical, then I think the fear of physics will easily you can overcome from it. Okay. So that is the only tricks. Okay, practice and practice. You have to do. No other alternatives are there. Clear? So you have to do the practice. I will upload more and more this type of problems so that you can practice a lot. Clear? So up to this for today's episode. So keep watching my channel continuously and regularly because I am uploading different type of videos. Clear? So which will be very much helpful for all of you. Clear? So thank you for watching.